Video lesson 11.1. So we're going to be dealing with piecewise functions and how to graph them. So first thing is just a little refresher, and let's remind ourselves, when do we have open circles and when do we have closed circles on a graph? So if you think back to your graphing inequalities, when do we use an open circle, right? And that is when we have something that is greater than or less than occurring. That's going to give me an open circle, right, when I plot my point. For a closed circle, we're going to have a less than or equal to or greater than or equal to. That's going to give us a shaded or colored in circle. Also, it would be when it's equal to. That is also one. But again, more commonly when we're dealing with these things, you have a lot of times inequalities, not just equal signs. But those are the things that you have to remember. So open circle for less than and greater than, closed circle, less than or equal to, greater than or equal to, and obviously equal as well. So in the past, we've dealt with graphing these single equations over a continuous domain, and that's fine. That's what we've been doing all year long. Now what's happening is you're going to see different equations. You're going to see different equations over different sections of the graph, right? Because the graphs tend to look like they're parts, like pieces of graphs stuck together, it's referred to as a piecewise function, right? Key thing here is a piecewise defined function is a function defined by at least two equations or pieces, each of which applies to a different part of the domain. So that's an important aspect to make sure you know. All right, if you don't, you have to have at least two pieces. So if you look at this example right here, this piecewise function is created by three parts, right? So the blue section here, the function here, f of x, is all of this together. So if you think of each one as an individual, like y equals, this would be y equals x plus 2. That's your blue linear function here. Now, if I just graphed y equals x plus 2, it would just be this line that would continue on forever and ever and ever and ever and straight as a linear function. But it's not. It's only a portion of it. So it's been restricted. That's what this part here is. This part here is your restriction. It's saying graph this part of this function only when x is less than or equal to -1. So as you can see, solid circle, and then the rest of the thing. Note it's a linear, so you can just count your slope here. Down one, left one, down one, left one, right? From there. The second part is your red section here, where f of x is equal to 1. So again, think of it as y equals 1. That's a horizontal line. So that would be, again, if it was just y equals 1, it would be all of this, right? It would be all of that. But I'm not dealing with all of it. I'm just dealing with this section here. So it goes from -1, as you can see here, to 1, right there. So it's only that red little section piece. And then lastly, x squared. Again, y equals x squared would be a parabola, which again, if I sketch that, it would look like that, right? But we don't want all of it, right? So we don't want the whole thing. We only want the portion of when x is greater than or equal to 1. So that's from here upwards. Notice, again, this one's not, there's only a very small graph here, so it's not a very defined thing, but make sure your key definitions and your characteristics of each part of the graphs are defined here. So again, this first one's linear. This second one is linear, it's horizontal. This second one is quadratic. So you notice that there's a slight curve to this portion of the line. Again, just because of how small of a portion this is, it's not a dramatically looking curve, but it is curved, all right? Because again, it's not a linear function, right, from there. All right, let's try doing a couple. So I have some steps for you to kind of go through here when doing it. So the way that I like to do it is, again, take each function, create a table that represents the values that you are going to be plotting, plot them, connect the portions of the functions, and then create that entire function. We're going to connect all of them utilizing the appropriate symbols, open circle, closed circle, etc. All right, so let's go through this. So let's do this first one here. This first one says when f of x is equal to -2 from x is less than 0, and when 5 when x is equal to 0, and from 1 when x is greater than 0. So this first part here, right, I'm going to do here, I'm going to call this the blue port, right? So really I have, I'm thinking y is equal to -2, right? It's a horizontal line, right? So xy for that. When x is less than 0, so less than 0, so 0, -1, -2, -3, so on and so forth. The other thing I like to do is, just so that I don't forget to do this when I graph, is what type of a point am I going to put it for this one? It's less than, that's an open circle, right? So I'm just going to put an open circle over here, right? It's open. And then I plot my points. Now again, I could just do this by plugging it in. We know it's already, whenever you have y equals a number, that's a horizontal line. So I'm going to have a constant y change here of -2. So just -2 for all of these. All right. From that, so I'm going to go over here. I'm going to plot that. So I've got an open circle at 0, -2. Open circle. -1, -2. I've got -2, -2. -3, -2, so on and so forth. So now if I took that part, I can create my line here, like so. Again, don't forget your arrow, because it does continue on forever in that direction. All right, let's do the second part. I'll do this one in red. So here I've got the function y equals 5. Again, horizontal line. It says when x is equal to 0. I only have one spot, 0. And that would be at 5. It's saying when it's equal to 0, right? From there. So that's going to be a closed circle, right? So I've got a closed circle at 0, 1, 2, 3, 4, 5. That puts me right here. And lastly, I'll do this one in green. We've got the function y is equal to 1, which is also a horizontal line, when x is greater than 0. So again, I'm going to start at 0, right, because this is greater than 1, 2, 3, 4. This is going to be an open circle, right? And what's happening? Again, it's still a horizontal line, so I'm still going to have just 1 for all of these, right? So I go at 0. I got 0, 1. Oops, that should be open. 0, 1. 1, 1, 2, 2, 3, 3, 4. 1, 1, 2, 1, 3, 1, 4, 1, so on and so forth. And we'll connect that like so. Again, don't forget your arrow. So here's your piecewise, right? Now they're not all touching, and that's fine. Doesn't have to be, right? They can be separate parts, right? But all together, all three of these things together create f of x, the function f of x, right? Each individual part is its own little piece, but together, all three of them create this f of x function, aka a piecewise function. All right, just a quick reminder when graphing. Again, remember the graph itself. Again, the x and the y automatically are in terms of a single unit by ones, unless you have indicated otherwise. So if you need to go up by a different factor, make sure you write them, but typically you're okay with that. All right, let's try a second one here. All right, so this one, again, I'll do this first part in blue. So I've got this first term, which would be y equals x, right? When x is less than or equal to 0. So less than or equal to 0. So starting at 0, -1, -2, -3, -4, so on and so forth. Again, now I can plug them in when y equals x. So when x is 0, y would be 0. When x is -1, y would be -1. So on and so forth. All right, so I can plot these. Again, I'm dealing with less than or equal to, so that's a closed circle at that point. So I've got 0, 0, which is closed, -1, -1, -2, -2, -3, -3, -4, -4, so on and so forth. So I'm just going to continue that here with my line. Draw my arrow. Notice I do extend it for whatever portion of the graph that I have. Again, I don't have to plot all the way here as long as you have the trend of what's going on, and then you can, but then draw the line through the entire portion of the graph. And again, don't forget your arrows when necessary. All right, let's do this part here. I'm going to do this part in green. So I've got y equals the x plus 1 portion, and I'm looking for when is x greater than 0. So again, starting at 0, 1, 2, 3, 4, 5, and so on and so forth. So plug them in. So when x is 0, 0 plus 1 is 1, y is 1. When x is 1, 1 plus 1 is 2, and 2 plus 1 is 3, 4, 5, 6, so on and so forth. So again, greater than, so this is open. So now I'm going to go 0, 1, have an open circle there. 1, 2, 2, 3, 3, 4, 4, 5, so on and so forth. And I can now connect them. That's going to look like this. And again, don't forget to put your arrow. All right. So when dealing here, again, you now have an entire function f of x, which is these two things put together. All right. It is a function because notice if you pass the vertical line test, anywhere I draw a vertical line, it only touches the graph once. Even at 0, where the y-axis. Again, because one is open, one is closed, I'm still a function, right? If they were both closed, that would not be a function. That's why it's important to note the points where it's open and closed. All right. So I'm going to give you guys a chance to try the other ones. All right. The other 3 examples here, they have some other examples to kind of use as practice. Again, this number 3 here is just like the one we just did, a little bit more involved from there. This one obviously has 3 of them going on, like we did on the first one, and then same thing with number 5, a little bit more involved. Now, one other thing is when you're doing here your tables, right? If you don't have a calculator, obviously you have to substitute it in yourself, come up with what it is. You can use a calculator, right? Y equals, and then plug it in. So if I just look at my second example for a second, I could do 2 plus 3x, right, for my first part. And then I can do 3 minus x for my second part, right? And then hit second graph, that gives me my table. Just be careful, you only want to select the parts on which you are actually trying to graph. So if I was doing this for number 3, right, I want x is less than or -1. So I would go, where is it -1? So when x is -1, right, and I'd have to scroll up here a little bit. There we go. So I need -1, -2, -3, -4, so on and so forth. And I need the y values associated to that one. Then I need where x is greater than or equal to -1. So at -1. And then I'm going to the second function. I would -1, 0, 1, 2, 3, so on and so forth. So if you're going to use the calculator, just make sure you're very diligent on copying down the table and the appropriate values, especially when there's a lot of them. I find when students plug like 2, 3, 4 functions in, again, with you speeding through it or trying to rush through the thing, a lot of times you might make mistakes on the points and the values. So make sure you're careful when doing that. So give you guys a chance to do that on your own, and then use these 3 for practice.